Right, good afternoon, all my chemistry students. I'm not exactly sure. This is probably going to be my third time recording this, but I think I finally have all the bugs worked out of it, so hopefully this will work this time. Okay, so this last section we're going to be doing naming alkanes, and I cannot stress enough that if your world did not have any alkanes, it would be vastly, vastly different than it is right now. Think about how you got to school today. You probably took some sort of motorized transportation. That would not be happening because the gasoline is hydrocarbons, the oils are hydrocarbons. You'd be going back to the riding a horse in the buggies, any medicine that you take, anything that has plastic, your water bottles, all of that stuff is hydrocarbons. Our world would be greatly different. And when we talk about these alkanes, the hydrocarbons is that magic city, the city of lights that I used to tell my children when they were little, Coke refinery at nighttime, how it looks like a little mini city. It's all producing and decomposing distillation of hydrocarbons, and everything is made up of carbon and hydrogen. So as we take a look at this first compound, I think I showed you this the first day of school. This is methane, and it's called methane because it has one carbon atom. And this is the naming system that we are going to be taking a look at. And you can see this first one, meth, has one carbon atom. This one has two, and this one's called ethane. And so it has to do with the prefixes that you have here. So if you take a look at the next slide, you can see that the basic principles, the name for an alkane is based on the Greek root with the suffix ane, ane. So if I have one carbon in the chain, it would be methane. 2 carbons, ethane. 3, propane. And you can see over here that the example I have oct tells us there are 8 carbons. ane tells us that it is an alkane. So we aren't going to be doing too much with this, but I do want you to add somewhere, I think you have a little bit of space here, that you can write that if it's ane, it means that it has a single bond between the carbon atoms. And we'll talk more about this later. But if it's ene, then it's going to be a double bond between the carbon atoms. And if it's yne, then it would be a triple bond. And that's just between the carbon atoms. And you'll see structures of that later, and we'll be reminded of this again. But for right now, we are just going to be dealing with the single bonds and ane. So how are we going to put this into action? So first we have 3 ways that we're going to do this. We're going to do the structural formula, the condensed formula, and the molecular formula. And as you can see, we have the examples propane and butane, both of which are examples that you have been in contact with. Propane is how you're probably heating your home, or if you have a propane tank for a gas grill. And then butane is what you have in a butane lighter. So the structural formula is how all the carbons come together. So the first thing I would analyze is I would look at prop, and I would say, yep, it's ane, so that means it's a single bond between the carbon atoms. So I'd look back on my prefixes, and prop is 3, it has 3 carbon atoms for prop. So I would draw my 3 carbon atoms, 1, 2, 3, and we're going to draw sticks in between, and these sticks are going to represent 2 electrons. So I have 2 electrons in each carbon atom. As you saw in the first structure, each carbon atom can make 1, 2, 3, 4 bonds. That means it has a total of 8 electrons, 2, 4, 6, 8. If I take a look at this carbon, 1, 2, 3, 4. This carbon, 1, 2, 3, 4, and they happen to be sharing there. But each carbon can make 4 bonds around it. So I need to do the same thing. So here for carbon, I have 1 that I've already drawn, 2, 3, 4. And at the end, we cannot have any empty sticks. We would draw hydrogens. This carbon has 1, 2, 3, 4. Carbon 1, 2, 3, 4. And draw your hydrogens at the end. So that is our structural formula that shows how and what is bonded to every single carbon. Now we're going to do the condensed formula. So the condensed formula is it shows what's bonded to each C. Now it depends if you want to draw this on your notes or not, but it shows what's on each C. So if I take a look at that C, you always start with the carbon. I have 3 hydrogens attached. Look at the second carbon here. I have 2 hydrogens attached, CH2. And my last carbon, I have 3 hydrogens attached, CH3. So that's our condensed formula. And then the molecular formula is kind of what we've been working in class. You just simply add them all up and write down the formula. So I have 3 carbons in my formula, and I have 3 plus 2 is 5, plus 3 more for the hydrogen, so it would be C3H8. And that would be my molecular formula. So if you want to try the next one on your own, you might want to pause this right now. Go ahead and try to draw butane and the structural, condensed, and molecular formula. Okay, well hopefully you pause that, and now I will write down the answers here. I have butane. But means 4 carbon atoms, and we talked about that each carbon atom can have a total of 4 bonds around it. So this carbon has 1, 2, 3, 4. Carbon has 2 bonds already, so I'm going to draw 2 more hydrogen. This one just needs 2 more hydrogen to make 4 bonds. And then this one at the end is going to need 3. So my condensed formula, again, is what is attached to each C. So it's CH3, CH2, CH2, and then CH3. And my molecular formula, hopefully you added them all up, and you saw that you had 4 carbon atoms. So it's C4, and then it's going to be H10 if I added them all up. Now, hopefully you saw a little pattern here. For my molecular formula, from 3 carbons, I had 8 hydrogen. Now I have 4 carbons, I have 10. So you should be seeing that we are doubling that number and adding 2. Doubling the number of carbons and adding 2. And that's the little molecular shortcut formula that I have written down here. N is the number of carbon atoms. So for example, if I give you that N is equal to 15 carbons, I don't think you want to take the time to draw that all out and count it all up. That would be a waste of your time. So let's just plug it in. So N is 15, so it'll be C15, H, and I'm going to go 2 times, use this formula right here, 2 times 15 is 30, plus 2 more is 32. So it's always going to be double the number of carbons and adding 2. So if I do another example of 20 carbons, where N is 20 carbons, then it's going to be C20, double that, and add 2 is going to be 42. Okay, so hopefully you got those down. And then we're going to talk about branched alkanes. They can't all be simple, straight chains like we just drew. So basic principles. For a branched hydrocarbon, use the longest continuous chain for the root name. So if you can see in my example here, when I go like this and I look at this chain, you can see that there is 6 carbons. 1, 2, 3, 4, 5, 6. However, when I go in this direction here, I only have 5. 1, 2, 3, 4, 5. So my longest chain is going to be 6 carbons. And when I look at my prefix, you are going to see that the prefix for 6 is hex. And so we're going to use that in our naming system. Now we're going to have things that are going to be matched or branched. So how do we do that? So the basic principles specify the names of the constituents by the carbon atom starting at the end closest to the branching. Again, what that means is we want to have the smallest number. So if you take a look, if I do the correct numbering here, you can see that this carbon is 1, 2, 3, and then I have my branch. If I start numbering the other way, I would have carbon 1, 2, 3, and the branch wouldn't happen until the 4th carbon. So that's why the blue numbering system is the correct way. So I have it on the 3rd carbon, which is going to play a part in just a second. And I have a methyl substitute, meth meaning 1 carbon, on that branch. So when I write this, you guys are going to see that I take my longest chain, 1, 2, 3, 4, 5, 6. So I have a hexane because it's a straight molecule, but on the 3rd molecule. So I'd write a 3 and do a dash. And then on that 3rd, I have what's called a methyl. So when it is a branch, all I do is I count how many carbons are on the branch, and I have 1 carbon here, so the prefix is meth, and add YL. So on the 3rd one, I have a methyl. And then what is the long chain? I have 6 carbons in my long chain, so it would be hexane. So someone would read that and they say, oh, I have hexane is a long chain. On the third carbon, I have one methyl, or one carbon. So let's try a couple of these. These can get complicated really quickly, so we're just going to try to keep them a little bit simple for you guys. So how I like to do this is I kind of like to read backwards. I know we read from right to left, but I like to read from we read from left to right, but when we do these, I like to go from the right-hand side and move to the left. So I have butane, so I look on my prefixes. But means 4 carbons, so I have a 4-carbon chain. I have 2-methyl. Now it doesn't matter if I start numbering from this end, 1, 2, or I start numbering from this end, 1, 2. It doesn't matter. You just need to start from one end. So 1, 2, I'm just going to draw it here. On the second one, I have a methyl. Meth means 1 carbon. And then I'm going to go around and I'm going to add my hydrogens. So this carbon has 1, 2, 3, 4. 1, 2, 3. I only need 1 hydrogen on that one. 1, 2, 3, 4. 1, 2, 3, 4. And this one needs 3. Now, this gets really messy really fast. And so what we're going to do is we're going to start dropping the hydrogens on these because it's a lot easier to draw the structures without them, but you just need to understand you're still going to put the sticks on there, but everyone's going to understand that there's a hydrogen left behind. Okay, so 3-ethylhexane. Let's draw this one. I'm going to erase this a little bit here. Hopefully you got that. Again, there goes the bow. I would like you guys to start from the right-hand side. So again, I have a hexane. So I'm going to draw my 6 carbons. Let's see, what do I got? 1, 2, 3, 4, 5, 6. And it says 3-ethylhexane. So 1, 2, 3. I'm going to draw, and it says ethyl. So Eth means that there are 2 carbons attached as a branch. Now just go around and put your sticks on here, but you don't have to write the H's. So I already have 1 stick here, 1, 2, 3, 4. Carbon 1, 2, 3, 4. This carbon 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Yes, I can count to 4, right? And then this one needs 2, and this one needs 3. So this would be 3-ethylhexane. Okay, we have another thing that if they are on the same number, we use a prefix di. So I want you to add letter C here, which I think you have room. We're going to draw 3-dimethylhexane. Okay, 3-dimethylhexane. So again, start from the end. Hexane, I need 6 of them. So go ahead and draw that. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, okay. Now, it's on the third carbon, 1, 2, 3, so I'm going to use that one as my third carbon. It says dimethyl. Di means that there's 2 of them, one above and one below. How do I know that? Well, if I look at the one up above, if it's 3-ethyl, that means they were attached, 2 of them together as a branch. When it's dimethyl, that means there has to be 1 on each side because it's a single branch. And then go ahead and go around and add all of your hydrogen sticks. And this should be now 3-dimethylhexane. When you draw a few more of these in your homework, I think it'll make a lot more sense. Okay, so now this is just another example of what I just did. If a substitute occurs more than once, use a prefix to show this. So you can see it's 2,3-dimethylpentane. So the first thing I would look, pentane. 1, 2, 3, 4, 5. So there's my long branch. Then dimethyl means I have single branches on the second and the third. So on the second, I have a methyl. On the third, I have a methyl. Now, I know that the di seems like it's repetitive. It kind of does to me too. Like, wouldn't just 2,3-methyl be sufficient? I would think so, but as the structures get more complicated, that's why we need some more prefixes. So you need to go ahead and draw 2,5-dimethylhexane, and go ahead and stop the video and see if you can draw it and then check it. Okay, and you can go around and add all the sticks, but this would be 2,5-dimethylhexane. Okay, I'm just checking to see how long. All right, this is getting a little bit long, so I am going to quickly go through the isomerism, sorry. Structural isotopes is when two or more molecules have the same number of atoms but different bonds. And so you guys can see here that I have 1, 2, 3, 4. So you should be looking up that that is butane. And then we have isobutane. I still have 1, 2, 3, 4, but it's a different arrangement. Can you see how this one is in a straight chain? And this one, they took it off. They took one off on the end right here, and then they moved it to here. So this is still 4 carbon atoms. It's still going to be butane, but we have a different way of naming it because it's now branched. So this top one, you would still say is butane, but this one, you have a branch on the second carbon. So you could definitely say that this is 2-methyl, and then 3 would be ethane. Now, you can see that the numbering gets very complicated very, very quickly. So if you take a look at the last slide that we have on here, it wants you to draw all the isomers of pentane. Now, pentane again means 5, and you probably think that that would be a lot of structures. You actually only need 3 structures that you need to draw here. So I will leave that and see if you can figure out those 3 structures. All right, hopefully I won't have any more problems with this video. You guys have a wonderful night, and I also want to say that I'm very, very pleased with what you guys have been doing in class. Really, really, just keep up the great work. You guys are doing an awesome job. And I will see you tomorrow.